Hello everyone, my name is Pawapat Prachyanusorn, and in this presentation I am presenting to you my application called the GOG Games Analysis Dashboard. So first let's talk about the objective first. My main objective was to create an interactive data analysis tool that can help users explore trends in the video game market. And the dataset I chose was from the GOG website, which is one of the biggest game distributors in the world. And this dataset contains over 15,000 games. And since I did not want the dashboard to be static and boring, the web application that I wrote will also be interactive. So for this presentation, it will be divided into three main parts. The first will be the live demo of the web application, as you can see here. The second part will be the brief code explanation, which will include libraries used, the code structure, as well as how each function works briefly. And the last part will be about self-evaluation. Okay, so for the first part, I will demonstrate how my program works. So in the program, as you can see on the topmost, there will be two tabs to toggle. So between the annual analysis and the full dataset deep dive. And below these two tabs, you can choose to see the analysis of four things. So the first one is the price analysis. The second one is the genre deep dive. The third is the top charts. And the last is developer and OS insights. And so, as you can see here for the full dataset, we have the price analysis of all games in the dataset as a bar chart. For the genre deep dive, we can see the top 10 most common genres across all games, and it is the adventure. And below, we can also see the price distribution by top genres. For the top charts tab, I include most popular games by review count, as well as top rated games, and you can scroll down this chart to see the last 10 of the top 20s. For the top rated games, I also included an interactive feature, which is the slider that the user can control. So if you want this table to display only games with more than, let's say, 500 reviews, you can scroll it to here and it will update, and all the games in the top rated games will be updated to contain only the ones that have more than 300 review counts. Lastly, the developer and OS insights. So I include the top 10 developers by game counts, also include the top 10 publishers, and as well as the OS support distribution, so that you can know which operating system supports the most number of games. And of course, it is the Windows. So let's go back to the annual analysis. In this page, if you scroll down, you can see that it has all of the analysis, the same one as the full dataset, but you can select the year so that you can deep dive into a specific year that you want to know the data. For example, if I select the 2021, the data will be different from if, let's say, I select the 2023. Okay, and at the top of the page, I also include a global overview of the dataset. So the total games, the average rating across all games, as well as the number of unique developers. And I also created a bar chart to visualize game releases by year, as you can see here. And these are basically the functions of my program. Okay, so let's move on to the second part, the code explanation. So there are four main libraries used in this program. The first one is the Streamlit framework, which is a framework for building web applications. So all of the web layout, the tabs, the widgets, they are created using this framework. The second library is the Pandas, which is a library for data analysis. So all of the data manipulation, the loading and cleaning of the data, were done through pandas. And the last two, the matplotlib and the seaborn, they are for plotting. So everything from bar charts to histogram, they are plotted using these two libraries. Seaborn is basically just a library built on top of matplotlib, which allows for more complex plots. And below is the setting for the matplotlib. Since my web is in dark theme, I also want my plots to be in dark theme, and that's why I have to implement this section here. Okay, so I tried to write this program following the best practices of coding. So the structure of this program is modular, and it contains 5 distinct functions to avoid code duplicate. Okay, so let's take a look at the first function first, the load and clean data function. So what this function does is basically loading in the data and cleaning it. And as you can see here, the parameter is set as default to be the game.csv file. I also implemented the try except blocks to prevent crash in case that the loaded data contains nothing. And I also decorated this function with the st.cachedata decorator, which is important because it tells Streamlit to store the clean data in memory so that it doesn't have to load in data and process it every time the user uses it. And this helps the performance quite a lot. This function, it reads the raw CSV file and performs all critical cleaning steps. Such as it turns the data in the date release date into the actual datetime objects for the program. And I also include one helper function for passing string lists. Since in the cells of the CSV file, it might look like a proper list, for example like this, it is actually a string. So this function is important in converting these string lists into proper lists that Python can work with. So as you have seen in the demo, there are 4 main analyses. The first one is the price, second one is the genre, the third one is the most popular games and highest rated games, the leaderboard, and the last one is the developer analysis. So I separated these analyses into their own function to prevent the code duplicate. Let me take the show genre analysis as an example. So this function is basically responsible for calculating and visualizing the most popular genres across the given data frame, right? And since a single game can belong to multiple genres, I couldn't just count the rows, but I had to use the pandas explode method to kind of separate these lists into individual rows for each genre. And then after that, I could count. Okay, so next let's take a look at the main function. So this function, it is like the director of the application. So this is where the configurations of my web app is done. As you can see here, set page config. And it is also where the annual and the full dataset deep dive tab is divided. So the most important job of this function is to manage data scope. For example, if the user is on the annual tab, which is the main tab 1, the main function will have to filter the data by year first and then passes that smaller slice to the charts. And if they are on the full dataset tab, which is here, the main tab 2, the function will have to pass the entire dataset. And this design allows me to reuse all of the analysis functions without rewriting a single line of code. And for the last 2 lines, they are just for running the app. And by the way, to run this Streamlit app, you have to type into the terminal Streamlit run and the name of the file, which is the main.py, and it will run the app. Okay, next is the self-evaluation part. So for the project implementation, my expected score is 20. That is because I believe that my project's completeness is full. So I used libraries that were not covered in class, including the Streamlit, Pandas, Matplotlib, and Seaborn. My program is also well over 100 lines of code, 200 plus, excluding all the comments and spaces, and it contains 6 functions, including the main function. And all the required knowledge were also included. So if else, loop, list, tuple, set, dictionary, string, they were all used. If else was used for error handlings, loop for data cleanup, which is the list comprehensions. For the data storing types, they were used for storing data and manipulating them, and string for passing. And as showcased in the code explanation part, my code follow proper programming practices because I use functions for each of my analysis, avoids the code duplication. For the presentation, my expected score is 8. I did clearly present the project objectives and provide a demonstration. I also explained how my project meets each specified criteria, and my presentation is within the 5 to 15 minute range. But the quality of my presentation is not on that level yet. The main reason is due to the fact that I work on this project alone, and as a 4th year student, I don't have the time. I initially planned to create a presentation slide, but I was short on time, and so that was not possible. For the report, my expected score is 9. All the required details were included. The structure of the project is also well organized, and I did go beyond simply showing images without explanations. But I gave myself a 9 because I believe that it can be more detailed, but as I told you, I didn't have that time. And the AI tool that I used was Gemini from Google. I used it to teach me how to use each library. So I had all the idea in mind, but if I did not know how to execute those ideas, I asked Gemini to walk me through it. It also helped me with structuring the code to follow best practices. Yes, so I think that's all. Thank you so much for listening.